In the last class, we were discussing about the and nitrogen oxides which are released from these car exhaust. Okay, and they contribute to photochemical smoke as well as acid rain, as well as toxic carbon monoxide and acidic nitrogen oxides. They also release unburned hydrocarbons, which are known as VOCs. VOCs means volatile organic compounds into the air. Some of these are carcinogens. Carcinogens means a compound which can cause cancer, and they can form PAN, peroxyacetyl nitrate, a contributor to photochemical smoke. So these we are studying the harmful effects of the incomplete combustion. Carbon monoxide is released, acidic nitrogen oxides are released. So they are known as volatile organic compounds. They release unburned hydrocarbons, which are known as volatile organic compounds. We are discussing this in the last class. We were discussing about the incomplete combustion, that carbon monoxide is released, right? Carbon monoxide is released, and the harmful effects of carbon monoxide is we have studied. Okay, so they release unburned hydrocarbons, which are known as volatile organic compounds, into the air, which are carcinogenic, which can cause cancer, which can form PAN, which is a major contributor to your photochemical smoke. Okay, now how can we control them? By reducing traffic emissions. Okay, so we have studied that we can use catalytic converters, remember, in the nitrogen and sulfur chapter. So motor vehicles can now be fitted with catalytic converters in their exhaust system. Once warmed up, catalytic converter can cause the following reaction to take place. What does the catalytic converter do? Oxidation of carbon monoxide to carbon dioxide, right? Reduction of nitrogen oxide to form harmless nitrogen gas, and the oxidation of your unburned hydrocarbons, that is your volatile organic compounds, to form carbon dioxide and water. Unfortunately, catalytic converters, it can do nothing to reduce the amount of carbon dioxide, because carbon dioxide is also a greenhouse gas. Okay, so it cannot do anything to produce the amount of carbon, to reduce the amount of carbon dioxide, which is a greenhouse gas which is given off in the exhaust gases of cars and trucks. So this is a catalytic converters. It reduces the pollutants from car exhaust. Pollutants means your nitrogen oxides and carbon monoxides and volatile organic hydrocarbons, volatile organic compounds. Precious metals such as platinum are coated on a honeycomb structure to provide a large surface area on which the reactions can occur. If the surface area is large, then the rate of reaction increases. Okay, so we can use the metals such as platinum to provide a large surface area on which the reaction can occur. So write it down. So these are the reactions. The following equation, it describes the reaction between carbon monoxide and nitrogen monoxide. Okay, it takes place on the surface of which metal? Platinum metal, in a catalytic converter. Carbon monoxide is oxidized to carbon dioxide, and nitrogen monoxide is oxidized, it is reduced to nitrogen. Some of the carbon monoxide gas can also be oxidized inside the hot catalytic converter to produce carbon dioxide. So note that more carbon dioxide is released. Here also carbon dioxide is released in this process. In this process also carbon dioxide is released. It is not a toxic gas, but still it is a pollutant because it is a greenhouse gas, because of its contribution to enhance global warming, which results in the climate change. So this is your homework question for today, that give the balance symbol equations for the complete combustion of heptane giving carbon dioxide and water. You just have to balance the equation. Combustion means reacting with oxygen. Methane, incomplete combustion. So you know what is the product? Carbon monoxide. Incomplete combustion, product is carbon monoxide and water. Name two pollutants from a car engine that can be oxidized in a catalytic converter. Name a pollutant that is reduced in a catalytic converter. Okay. And which pollutant from a car engine is not reduced by the use of a catalytic converter, and what environmental problem does this pollutant contribute to? So I've explained all the things. You just have to copy and write down the solutions. Okay, now we'll learn the substitution reactions of alkanes. As I told you that alkanes are generally unreactive, but they form two types of reaction. One is the combustion reaction and the other is the substitution reaction. So they undergo substitution reaction with halogens in the presence of sunlight. So consider the reaction between ethane and chlorine. in the sunlight. So we get what? Chloroethane. One HCl is removed and we get chloroethane. So there are, in this reaction, there are 3 steps. First step is initiation step. In initiation step, the mechanism of this is breaking of the Cl-Cl bond, breaking of the chlorine bond by energy from ultraviolet light. So which type of cleavage occurs here? Homolytic cleavage, okay, and the formation of free radicals occur. So 2Cl free radicals are formed. In which step? In the initiation step. Okay, so as the Cl-Cl bond breaks, each chlorine atom takes one electron from the pair of electrons in the Cl-Cl bond. This is an example of homolytic fission of a covalent bond because Cl2 is what? Cl2 is non-polar. So no positive.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
No partial positive and no partial negative charges are developed here. The 2 chlorine atoms are formed. That means 2 chlorine atoms are known as your free radicals, which have an unpaired electrons. So they are called your free radicals. Okay, so see this reaction. This is your hexane and bromine. Bromine is reddish brown in color and hexane is colorless. So you have to mix them. This is your alkane. You have to mix them and leave it in sunlight. So reaction to give a mixture of bromohexanes, bromine color disappear. The color of bromine will disappear. And if you mix and place in a dark cupboard, that means no light is there. So no reaction will happen. If light is there, if sunlight is there, then the reaction will happen and bromine will decolorize itself. Okay, the substitution reaction takes place between alkanes and bromine in sunlight only, but there is no reaction in the darkness. Is it clear?
Yes.
So write down the substitution reaction of alkanes. So you have to always remember that substitution reaction, it takes place in sunlight only. If you mix them and place them in a dark cupboard, then no reaction will occur. So first step is clear, that is your initiation step, okay, that involves the breaking of the Cl-Cl bond, okay, homolytic cleavage occurs and the formation of free radicals happen. Second step is propagation step. So free radicals, they are very reactive, okay, because they are unstable. If they are unstable, then they are very reactive. They will attack the normally unreactive alkanes and a chlorine free radical will attack the ethane molecule. See how it occurs. This is my ethane molecule. Okay, this is a chlorine free radical which is very reactive. It attacks the ethane molecule. HCl removes. Okay, in this propagation step, CH bond in CH3 CH3. This is my CH3 CH3. So the CH bond, this bond, it breaks homolytically. Okay, that means one free radical on hydrogen and one free radical on the carbon. So we have this type of molecule. Dot free radical on this carbon plus H free radical. An ethyl free radical, this is what? This is CH3 CH2 free radical. It is produced. Then what happens? It can attack a chlorine molecule forming chloroethane and regenerating a chlorine free radical. So it will attack with the chlorine free radical. Okay. We have a chlorine free radical in the first reaction. So this free radical and this free radical combine with each other and we have a CH3 CH2Cl plus chlorine free radical. It will combine with chlorine. One chlorine will combine with this free radical and one chlorine it liberates as a free radical. Then the first propagation step can be repeated. Then this step is repeated again as the chlorine free radical can attack. Now this is free. It will attack another ethane molecule. This again forms the ethyl free radical and this ethyl free radical, it regenerates another chlorine free radical and this process continues. That means this process propagates in steps. So propagation usually refers to growing new plants in biology. In this mechanism, the substitution reaction progresses, okay, grows in a type of chain reaction. So this is known as your propagation step. Okay, so write it down. If there's confusion in any line, you may ask. Okay, so write it down and write by understanding each and every line. So this reaction which we have studied just now, it is not suitable for preparing specific halogenalkenes. because here we get a mixture of substitution products. In the reaction between ethane and chlorine, products can include many different chloroalkanes, 1,1-dichloroethane, 1,1,1-trichloroethane, 1,2-dichloroethane, 1,1,2-trichloroethane. We get many more products, okay, because free radical can combine with anything here, any CH bond, as well as chloroethane. If there is enough chlorine present, if chlorine is in excess, then we get hexachloroethane. All the hydrogen atoms are substituted with chlorine. So this variety of chloroalkane products, it results from propagation steps in which a chlorine free radical attacks a chloroalkane already formed. For example, this is your ethyl chloride. When it reacts with a free radical, we get this. This can then be followed by, then again chlorine reacts. Okay, chlorine, two free radicals form. One free radical combined with this, we have 1,2-dichloroethane plus chlorine free radical. The more chlorine gas in the reaction mixture to start with, greater the proportion of chlorine atoms in the chloroalkane molecules formed. So this is your propagation step. So first step is initiation step, second step is propagation step, and the third step is termination step. Whenever two free radicals meet, they will react with each other, a bond is formed, single molecule is the only product. As no free radicals are made that can carry on the reaction sequence, so the chain reaction stops or terminates. So here this free radical is combined with this free radical to form chloroethane. Here this free radical combines with this free radical to form butane. So now the steps will end, chain reaction will stop, it will terminate in the termination step. Okay, so in the initiation step, what happens? We start with a molecule and get two free radicals formed. Okay, chlorine radical and chlorine radical. In each propagation step, we start with a molecule and a free radical and get a different molecule and a different free radical form. And in the termination step, last step, we start with two free radicals which combine with each other and end up with a molecule. And there are no free radicals now in the termination step. So this is a summary of all these three steps.